All right, so now that we've got some background in understanding the volume formulas for pyramids and cones, let's go through some practice examples together. So the first thing that I usually start with when I'm looking at a volume question is I first try to identify the figure that I'm looking at. And so I can clearly see that it's a pyramid, but what kind of pyramid is it? Well, if I look at the base here is a triangle, and so that actually makes this fairly simple because I know what the formula is for a triangular base. So I know that the volume of any pyramid is going to be the area of the base times the height of the entire pyramid divided by 3, because a pyramid has the 1/3 of the volume that that a prism does. So now, well, what is the base? The base is a triangle, and I know that the formula for a triangle is little b, the base of the triangle, times the height of that triangle divided by 2. Okay, and I know, and now I know that I'm going to multiply that by the height, and that whole thing, because of this divided by 3 here, I'm going to divide the whole thing by 3. Once we start to fill this in, then we can get this. Alternatively, you may want to calculate the base of your triangle on its own in a corner. And so, you know, that is another way to show that, would be to just calculate the area of that base first and then just plug in the value directly. So either way you want to do that is fine. Okay, so for instance, maybe I want to calculate the area of my little triangular base over here and say, well, I can see that this triangle base right here has its own base at 8 and its own height at 14. And then when I divide that by 2, that will give me the area, its area, right? So 7 times 8 is 56. And so 56 units, square units, is what my base is. So I can plug that in directly right in here, or I can solve it separately, as I did here. So working that out, instead of base times height divided by 2, I'm going to put the value that I figured that to be, and that's 56. Now I need to look at the height of the entire pyramid, and the entire pyramid, going from the top all the way down to the center, is 17 units long. And then I'm going to divide that whole thing by 3. So now at this point, I need to grab my calculator and plug all of this in so that I can get a solution. So 56 times 17 divided by 3 ends up giving me, I'm going to start it up here, about, if I round to the nearest whole, 317 units, but they're squared units, so I'm going to write, or cubed units rather, so units cubed because it's volume, and volume always has cubic units. Hopefully that example made sense. If not, just stop the video, maybe rewatch it, and write down some questions that you might have for me at the next class. All right, so here is a second example. In this case, I have a cone, and I think it's pretty clear that it's a cone. I know that its volume is going to be equal to the area of its base divided by its height, right? And so, well, what is its base? Its base happens to be this circle right here, right? There's my circular base. And so the formula for the area of a circle we've discussed as being pi r squared. And then this h describes the height of the entire cone. But I've forgotten something. I've forgotten that if I have a cone, I don't have a cylinder, and a cone has 1/3 the volume of a cylinder with the same base and height. So I need to divide all of this by 3. Now I'm ready to move on. So pi is the button on my calculator I want to press. I look at my diagram and I can see in this case that they've given me the radius. Okay, the radius happens to be 5. So I'm going to put in 5 into my formula and then I'm going to square it as the formula tells me to. Just a reminder that 5 squared does not mean 5 times 2. It means 5 times itself, 5 times 5. Okay, and then the big H describes the height of this entire cone, which happens to be this 15 right here. Now I'm going to divide the whole thing by 3 to get 1/3 of the volume of the analogous cylinder. So now we're ready to plug this all into our calculator. So I have 3.14, pressing the pi button, times 5 squared times 15. I'm going to divide that by 3, and that gives me a little over 392, 392.6. So I'm going to round that to the nearest whole, and that gives me 393 cubic units, so units cubed. In this case, they're not giving me whether it's centimeters or meters, so I'm going to include just the word units to show that I know that it's a measurement of some description. Okay, and so here's our final example. We really want to be cautious here in doing this problem because you may notice, I'm going to highlight for you, that they don't actually give us the height of this pyramid. They give us this line right over here, which is just the side length. So the side of that face. That is actually not the height of the pyramid itself. So we're going to have to do some work ahead of time maybe to figure that out. So this may be hard for some of you to visualize. I'm going to do my best to explain it. Okay, but if I take this line right here to the top of to the vertex or the top of that pyramid, and I take this line along the side, and then I connect the line right here, then you may see that if I flip this around and pull it outside, if I were looking at it head on, like head on this way, that it would actually form a right angled triangle. Okay, something that looks like this. And so let's fill in what we know about that triangle. Well, I do know that the hypotenuse here is 25. Okay, and I know that the height of the whole pyramid is really represented by that one side of that right angled triangle. So I'm going to call it H. And then here's another tricky part. So remember, I know that the height is measured from the center of that pyramid. And so the line going to the exterior side here is going to have to be half of the width of that base. So that if I know that this whole thing right here is, this whole side is 14, then what must the length halfway through, which would connect to the center? Well, it would have to be 7, right? So that means that this length right here would also be 7 units in length. Kind of tricky. Okay, and so once I figure that out, then I will then have not little h, I'm going to call this big H because I need to remember in my formula that big H means the height of the entire figure, not just the height of any parts of the base. All right, so I'm going to go ahead and solve that. Okay, so I know Pythagorean theorem tells me that my hypotenuse squared is equal to my other two sides squared, and then add it in together. Right? So we've got a little bit of math to do here. I'm going to pull out my calculator and work out what I don't know off the top of my head. So H squared, I know 7 squared happens to be 49, and 25 squared gives me 625. Now I need to get my H squared by itself, so I'm going to subtract 49. Whatever I do to one side, I do to the other. And that will will give me my h squared as being 576. So how do I undo a square? Well, I take the square root. Whatever I do to one side, I do to the other. And so that will give me my height just by taking the square root of that value. And that gives me 24 exactly. That's kind of convenient. Okay, so that's going to be 24 units in height. Okay. So now I can go ahead and I can say that the height of this pyramid is 24 units in height. But I still haven't finished my work because I need to continue on and figure out what the volume is. I only know the height. So I'm going to get rid of some of this here and we're going to carry on. Okay, so volume of a pyramid is going to be the area of my base times my height, which I just figured out, divided by 3. So, well, what is my base in this case? My base looks like it's a cube, right? So we're going to assume that it's a cube and say that I have a square base. So that means that this side over here will be 14 as well. So, given that, I'm going to go ahead and perform this calculation. So what is my base? Well, my base is going to have to be calculated by taking the length and multiplying by the width. Okay, big H I just found, and I'm going to divide that by 3. So if my length is 14, my width is 14, and my big height, remember, was that 24 that I figured out? That's this guy right in here. And I'm going to divide that by 3. So 24. So 14 times 14 times 24 divided by 3 gives me the total volume of this pyramid as being 1,568 square or cubic units. Okay, that was a tough one. Again, if you have any questions about that, make sure that you ask me and I'll be happy to help you out. Okay, the remainder of the questions for the section are in your workbook. You should have already completed 1 and 2 by now. So 3 to 10 are your responsibility to be working on for the period. Thanks so much.